Hello friends, welcome back to CSharp.net online training video series. In this video, we are going to discuss multicast delegate in C# with examples. As part of this video, we are going to discuss the following 5 pointers. We will discuss what is multicast delegate in C#. Then we will discuss how to create multicast delegate in C#. Then we will discuss the different ways to create multicast delegate in C#, right? And finally, we will discuss multicast delegate with return type and out parameters. We'll see example how to use return type with multicast delegate, and we'll see example how to use output parameter with multicast delegate. So before understanding multicast delegate, let us have a look what is a delegate. We have already discussed a delegate in our previous video, so please watch our previous video before proceeding to this video, right? So what is a delegate? In simple word, we can say that delegate is a types of function pointer, right? Delegate is a types of function pointer. What it means? It means the delegate holds the reference of a method or function, and when we invoke the delegate, the method it refers is going to be executed. The delegate signature and the method it points to must have the same signature. While creating the delegate instance, we need to pass the method as a parameter to the delegate constructor, right? This is what we have already discussed in our last video. So see, so this is, okay, let us understand this with an example. So this is nothing but your delegate. So you can see by using the delegate keyword, we are creating the delegate. And in this delegate, this is taking two parameter. One is integer hours and another is work type enum, right? And this is the delegate signature. And if you look at this handler method, right, this method, it is also same signature as this delegate. You can see the return type is void. Here the return type is void. Delegate is access specifier is public, and here the access specifier is public. This is taking two parameter integer and work type, and here also it is taking two parameter integer and work type. That means the signature of the handler method and the signature of the delegate method must be same. Once you create your delegate and once you define the handler method, then you need to create an instance of the delegate. This is the step 3. You can see I'm creating one instance of the delegate. So technically, if you look at this delegate, so when the compiler sees this delegate keyword, then internally it will convert this delegate to a class, and that class name is going to work perform handler, same name as the delegate name. So as it is a class, so you can create an instance of this class, and while creating the instance, you need to pass the method, right, that you want to execute when you invoke the delegate instance. In this case, when I invoke this delegate instance, I want to execute this method, so I'm passing this method as a parameter to the delegate constructor, right? And when we invoke the delegate, right, so we can invoke the delegate in two ways, like a function call, or you can also invoke the delegate by calling the invoke method, right? When we invoke the delegate, the method it points to, in this case, this manager underscore work perform method is going to be executed as this delegate refer to this function, and this function is going to be executed when we invoke the delegate. So delegate are called as a types of function pointer, right? So the point what we discussed is nothing but this, right? Again, we discussed that there are two types of a delegate. One is single cast delegate and another is multicast delegate. In this case, you can see this delegate pointing to a single method, right? One method is referred by this delegate. So we can say this is a single cast delegate if the method, right, if the delegate refer to multiple method, or if multiple method are registered with the delegate, then we can say it is a multicast delegate. And single cast delegate in detail we have already discussed in our previous video, and today we are going to keep focus on this multicast delegate, right? So what is multicast delegate? A multicast delegate is a delegate that hold the reference of more than one handler functions or handler methods, right? If you are creating a delegate and if that delegate referring to multiple functions, then it is nothing but multicast delegate. And when we invoke the multicast delegate, then all the functions which are referred by the delegate are going to be invoked, right? If you want to call multiple method using a delegate, then all the delegate must have the same signature as the delegate signature. This is the same thing, right? If you are creating a delegate to the constructor, if you are passing one method, then that method signature should be same as the delegate signature. And if you are trying to pass multiple method, right, then in that case, all the methods should have the same signature as the delegate signature, right? If this is not clear at the moment, don't worry, we will see this in some time, right? So a multicast delegate is just an array of multiple pipelines or multiple delegates. So multicast delegate means it is an array of delegates, or you can say it is a array of pipelines, right? The delegates are going to be invoked in the same order as they are placed in the invocation list. See, whenever we create a multicast delegate, we are going to add multiple methods, right? The order in which we are adding the methods, right? In the same order, the method are going to be executed, right? From the invocation list. So what is an invocation list? An invocation list is nothing but an array of delegates or pipeline where each pipeline will dump data into a different method, right? If this statement is not clear at this moment, right, don't worry, we'll understand this statement once we start discussing the program, right? Let us try to understand the multicast delegate. Okay, so this is one example. You can see this example is without using a delegate, and it's a simple example. I'm having this rectangle class, and in this class I'm declaring two methods. One is get area and another is get parameter, right? Get perimeter. In this case, this get area method taking two double type parameter, return type is void, and this get perimeter method is also taking two double type parameter and the return type is void, right? And this get area method is going to print the area of the rectangle, and this perimeter method is going to print the perimeter of the rectangle. And from the main method, what we are doing, we are just creating an instance of this rectangle class, and then I'm invoking the get area and get perimeter method. So now if I run the application, then I will see the output as expected, right? Get area method is executed first, and it will print the area of the rectangle based on the input values we are providing, and the perimeter is also going to do the same thing, right? So based on the input values, it is going to print the value of the rectangle, right? Perimeter of the rectangle. That is fine. Now, what is our requirement? Our requirement is to execute these two methods using delegate, right? So I'm going to execute these two methods using delegate, right? So in the example we have created, okay, we have already discussed. Now what we want to do is we want to execute these two methods using the delegate. So for that, what we need to do? For that, we need to create one delegate whose signature is going to be same as the signature of this method. Then we need to create an instance of the delegate. And when we create an instance of this delegate, then we need to register these two methods to the delegate instance. And when we invoke the delegate instance, then these two methods are going to be executed, right? See, okay, let me copy this code and let me show you the things practically, right? Okay, now you can see this is the same example, same rectangle class having the same two method, but now I'm creating one delegate, and you can see this delegate signature is same as this two method signature. The delegate signature is going to be return type is void, and it is taking two double type parameter, same as the get area and get perimeter method. You can see get area method, get perimeter method, both are having the return type void, and both are taking two double type parameter. That means now our method signature and the delegate signature is same. Now I'm creating one rectangle object. Why I'm creating rectangle object? Because this is a non-static method. As it is a non-static method, while creating the delegate instance, I need to pass that method as a parameter. As it is non-static, I need to specify that method name by using the object, right? So yeah, another way, see, in this is one way to register the method with the delegate, and another way is this one, right? This is also another way you can also register method like this, right? So in this case, we have registered one method with this delegate instance, rectangle delegate, right? So both approaches is exist. So you can use as per your preferable approach. So I'm interested with this one, so I'm going with this approach, right? So in this case, this is a single cast delegate. Why? At this moment, at line number 18, this rectangle delegate will point to one method only. Is it possible that this rectangle object is going to point multiple method? Can we register this get perimeter method with this rectangle delegate? Yes, it is possible. How? By using the plus equals to operator. So you can see this operator is nothing but binding operator, and it will bind this get perimeter method with this rectangle delegate object, right? So already this delegate object having one method, and currently I'm adding another method by using this plus equals to operator. That means now this rectangle delegate having two different methods, right? That means this rectangle delegate having two pipelines, or you can say it is having two delegates, one delegate pointing to this method and another delegate pointing to this method, or you can say one pipeline, right, is going to dump the data into this get area method and another pipeline going to dump the data into this get perimeter method. That means in this case, if you call this get invocation list method, right, and I believe, and guys, this method is available in the delegate class, and if you go to the definition of this class, then you will see that this property is available in multicast delegate class, and whenever we create our delegate, that delegate is inherited from this multicast delegate class only, right? So if you see this property is available in multicast delegate class, okay, let me build the solution and let me show you that behind the scene, right? Behind the scene means behind the scene when compiler see this delegate keyword, then it will convert this rectangle delegate to a class, and that class is going to be inherited from multicast delegate class. Okay. Okay, so let me go to the location where the exe file is generated. The exe file is generated in this location. Let me open the Visual Studio command prompt, right? I'm just opening the Visual Studio command prompt, right? Open the Visual Studio command prompt, then type ILDSM. ILDSM. So what I'm trying to do is I'm just going to show you the IL code of this application, right? So go to the location where the exe file is generated, select the exe file, click on the open button, and you will see that currently our this is multicast delegate. This is nothing but your namespace. This namespace currently having two classes. One is rectangle, another is rectangle delegate. Now, if you come to this rectangle class we have created, do you have any class with the name rectangle delegate in this namespace? No. Then from where this class is coming? Now this class is going to be provided by the compiler. How compiler going to provide this class means compiler see this syntax, right? Compiler see this delegate syntax, and when compiler find this delegate keyword, he will convert this class, this rectangle delegate to a class, and that class is going to be inherited from the multicast delegate. You can see this is extend multicast delegate, and this multicast delegate belongs to the same system namespace. Now, if you go to this one, the namespace is system, and this is the multicast delegate. As our class is inherited from the multicast delegate, so using our class instance, we can invoke this property. And this property, what we are invoking, you can see here. This is nothing but that property. Then what this property is going to return, this property is going to, sorry, this is not a property, this is a method, and this get invocation list method is going to return an array of a delegate. Then what is that array of a delegate having? And that array of a delegate is having the number of a delegate you registered on the rectangle in the delegate. So this is my multicast delegate, and in this delegate, I'm registering two methods, right? I'm registering two method means two delegates I'm registering with this multicast delegate, and that list it is going to return in this delegate array. The first pipeline will hold this information about this method, or the first delegate will have a link with this method, right? And the second delegate is right. The second delegate means the index position 1 is going to point to this method. That means in this case, first we registered this method, second we registered this method. So the way or the order in which we are registering this method, in the same order the method are going to be invoked when we invoke this rectangle delegate. So in this case, you will see this invocation list means it is going to show you that two delegates are registered with this rectangle delegate. That name you will see here. And then I'm invoking the multicast delegate. And we already discussed we have two ways to invoke the delegate. One, you can invoke the delegate instance like a method by passing the required parameter, or you can also use the invoke method, right? And if from where this invoke method is coming, this invoke method is provided by the compiler, right? If you go to the definition of our rectangle delegate class, then you will see that there is a method called invoke, right? And that invoke method is going to be provided by the compiler, right? So you can invoke the rectangle instance like this, or you can invoke the rectangle object like this. So it is up to you. I generally prefer to use the invoke method because it explicitly specifies that I am going to invoke the delegate, right? And once you invoke this method, the first which one is registered in the delegate, this get area method. So first get area method is going to be invoked, and then The second, we are invoking the registering the get perimeter method. So second, this get perimeter method is going to be invoked, right? So how we are going to register multiple delegate means by using the plus minus equals to operator. Right now if you want to remove one of the existing delegate from the multicast delegate, then what is the process? Now you simply need to use minus equals to operator. In this case, what method I'm removing from the delegate instance means I'm removing the get perimeter method, and in this time if I am going to invoke the delegate instance, then only the get area method is going to be executed, because we are just removing this one. So first invoke will invoke both the method, and once we remove the get perimeter method, then once I invoke the delegate, it is going to invoke only the get area method. Let's okay. So before running this application, I need to close this ILDSM tool. So I close this one. Now my application is running, and once it run the application, then you will see that first this is invocation list currently. So in this case, when I call this invocation list method, right, it is going to return me a delegate array which contains two pipelines, or which contains two delegate. Which delegate? One delegate is for get area method and another delegate for get perimeter method. And you can see both the delegate signature are going to be same. So in this case, it is going to be rectangle delegate, right? Then I'm invoking the multicast delegate. When I invoke the multicast delegate, you can see area method and perimeter method both are going to be execute, right? And then I remove this get perimeter method, and then I invoke this delegate again. And in this time, as get perimeter method is removed, so only area method is there. So you can see area method is executed, right? So this is how multicast delegate is working in C#. Right. So another approach of creating multicast delegates. So in this case, so what we have discussed in the previous example, we have discussed by using the plus equal operator, we are going to add multiple delegate instance to a delegate, right? So that is nothing but multicast delegate. So in this case, I'm going to show you different approaches, right? So first of all, you can see this is my math delegate, and in this math delegate, it is taking two integer parameter and the return type is void. So what is our requirement? Our requirement is we are going to perform different kind of arithmetic operation, like add operation, sum operation, multiple operation, and division operation. And we are going to perform the operation based on two integer numbers. So this is add method. It is going to add the two input number it receives. And if you look at the signature of add method and math delegate, it is going to be same. The return type is void. Here add method return type is void. The delegate access specifier is public. Here the add method access specifier is public, and the delegate taking two integer parameter, and it is also taking two integer parameter. That means the signature of this method and this add method is going to be same, right? And remember, this is a static method. And the same thing I'm also doing with the sub method. It is going to perform the subtraction operator, and the signature is also same as the math delegate, right? And again, it is a static method. Now coming to the mul method, it is going to perform the multiplication operation, and its signature is same as the math delegate. But in this case, it is not a static method; it is a non-static method, right? And this division function is there. Its signature is also same as the math delegate, but this is a non-static method, and it is going to perform the division operation. That means currently we have a four method. Out of a four method, two are static and two are non-static, and all the four method signature is same as the delegate signature. Right. Now what we are going to do, we are going to create a multicast delegate, and in that delegate we are going to add all these four methods, right? But remember, the static method you can add by using the class name or directly if both are present in the same class. And for non-static method, you need to create an instance of the program class, and using that instance only you need to register this small and deep function. So now we are not going to use that plus equal operator. We are going to use a different approach to create a multicast delegate. First of all, I'm creating an instance of program class because I need to register some non-static method, right? So first of all, I'm creating one delegate, and this delegate is pointing to the add method, and you can see add method is a static method, and this this object creation statement and this method belongs to the same class, so you can directly access the add method like this. Even you can access the static method by using the class name. So here you can see I'm creating another delegate instance, and in this time I'm invoking the sub method by using I'm registering the sub method by using the class name. So in this case, class name is not mandatory, but if you use, then that is not an issue. But remember, other two method, mol and div, they are non-static method. And while registering this method, right, with the delegate, we need to use the instance. So here you can see I'm using the instance of the program class to register mol method and the div method. Currently, there are four delegates, right? Currently, you can see there are four delegate, and each delegate pointing to a different method. So it is a single cast delegate, it is a single cast delegate, and it is also a single cast delegate, and it is also a single cast delegate. So we have created four delegate instances. Now, what is our requirement? We are going to add, right? We are going to add the delegate, right? We are going to add the delegate to a multicast delegate. We are going to add all these four delegates to a multicast delegate. So what I'm trying to do is I'm creating another delegate variable of type, the same type, math delegate. And in this delegate, I'm going to add all the four delegates. So you can say delegate 1, delegate 2, delegate 3, and delegate 4. What is the sequence? The sequence is first I'm adding delegate 1, means that delegate 1 is going to be stored in the invocation list, or you can say in the delegate array 0th position. This delegate 2 is going to be stored in the delegate array 1 position, index position 1. This is index position 2. This is index position 3. That means the important is the order on in which you are adding the delegate, right? Why? Because in the same order, the method are going to be executed only when you invoke this delegate 5, right? So in this case, you can see delegate 5 invocation list. That means this method now going to return me one delegate array with four elements, right? One element or one handler method pointing to this add method, another handler method or another delegate pointing to this sub method, the next delegate pointing to mol method, and the final delegate pointing to div method. That means currently this delegate array having four elements, and you can see when we loop through this for each loop, four elements are going to be printed. That means printed means the delegate name it is going to print. Delegate name means what is the namespace and what is the name of the delegate. That is what it is going to display, right? Then I'm invoking the delegate using the invoke method, and even you can also invoke this delegate directly in the sense you can also invoke the method like this. But I generally prefer to use invoke method, and when you invoke this method, the sequence in which the delegates are added, in the same sequence the methods are going to be executed. First you add a delegate 1 point to add method means first add method is going to be executed. Then you add a delegate 2 point to sub method means then sub method is going to be executed. Then div method, and then the fourth method is going to be executed. So do one thing, let replace this one. So I'm adding the delegate 3 in the delegate 4, and then I'm adding delegate 3. So in this sequence, you can see the third one is the div method, and the last one is nothing but your mol method. So in this sequence, the method are going to be executed. Then if you want to remove one delegate, right, then you can remove by using the minus equal operator like this. Right. So in this case, when you invoke this one, right, when you invoke this one, all the four methods are going to be executed. When you invoke this one, apart from delegate 2 means this sub method, add mol and div method are going to be executed. But remember, before executing the div method, before executing the mol method, div method is going to be executed because we have added that delegate, right, before delegate 3. Right. That means first div method, then the mol method is going to be executed. Okay, let me run the application and see the output, right? So it should be first invocation list. It is going to return me 4 delegate instances because we have added 4 delegate into the delegate 5, and we are printing that we are calling the get invocation list method on delegate 5. So it is going to return me 4 delegates, right? One delegate array with 4 elements, right? That is fine. Then we are invoking the multicast delegate. You can see addition, subtraction, division, and multiplication. Why division first, then multiplication means in the same way we have added delegate 4 first, then delegate 3, delegate 4 means division. So you can see division method executed first, and then multiplication method is executed, right? And then we have removed one delegate, right? Which delegate we remove? Delegate 2. Delegate 2 means it is pointing to the sub method, and you can see in this second invocation the sub method is not executed because that is we have removed from the invocation list, right? This is how you can create delegate and the multicast delegate, or you can remove and add multiple delegates, right? Now, a multicast delegate invokes the method in the same order in which they are added to the invocation list, and that we have already seen, right? The order in which we have added the delegates, right? In the same order, the methods are going to be executed, right? And as of now, the example we have discussed using multicast delegate are not returning anything. That is the return type is void. You can see all the delegates. So delegate return type is void, and in this case, the method return type is also going to be void. That means they are not returning anything. Now what happens if the delegate has a return, right? So apart from void, if we are putting integer, right, then what will be the output and what is going to be happen, right? If the delegate has a return type other than void, and if the delegate is a multicast delegate, then only the value of the last invoked method will be returned, right? Along the same line, if the delegate has an output parameter, the value of the output parameter will be the value assigned by the last invoked method from the invocation list, right? In this case, which method is executed first? This one. So if this one means the small method, right? So if this return type is there, if you are using integer, that means you have to write integer in all the four methods. Then what this method is going to be written, that will be the return type of the delegate. And if you are using some output parameter, then what this method set for the output parameter, that parameter is going to be the return value, right? Okay, let us try to understand this with some examples, right? Currently, okay, yeah. So this is my method. So here you can say I'm creating one sample delegate, and this delegate doesn't take any parameter, but it is going to return one integer value. And to the same signature, what I'm trying to do is I'm creating two method. One is method one, and this method one is going to return one, and this is the second method which is going to return 2. Right now, what I'm trying to do is I'm creating one sample delegate instance, and first I'm registering method 1, second I'm registering method 2. And when I invoke the delegate, right, that delegate, in this case, first this method is going to be returned, the return value is 1. Second, this method is going to be returned, the return value is 2. So which one is the last in the invocation list? Method 2 is the last in the invocation list. What this method returning? This method returning 2. That means this value written by the delegate is going to be 2. The last invocation method in this sequence is method 2. What value that method is returning, that will be returned by the delegate. So in this case, if you run this application, then you will see that it is going to return 2, right? Okay, let me run the application. You can see first method 1 is executed, second method 2 is executed, but the return value is going to be 2. Now let me, for clarity, let me change the sequence, right? Let me change the sequence. So in this case, I'm registering method 2 first, and then registering method 1. That means first method 2 is going to be executed, then method 1 is going to be executed, and method 1 is the last one in the sequence. So method 1 is returning 1, so the delegate return is going to be 1. So you can see return value is 1. So this is how the return type is work with the delegate, right? Now let us see the same example using output parameter, right? The same thing is also going to happen. If you are passing some output parameter, then the output parameter, the variable which is set, the output parameter variable which is set by the last invoked method, that value is going to be returned, right? So in this case, you can see this is the same sample delegate, but in this case, the return type is void, but it is taking one integer parameter, right? And that integer parameter, so okay, let me change the name. So this is my integer parameter, and this integer parameter is going to be set by method 1. It is setting the value to 1. Method 2 is also setting that value to 2. So in this case, when I invoke this delegate, I also need to pass one output parameter. In this case, this output parameter value is going to be set by method 1 as well as by method 2, right? In this case, which value it is going to return? It is going to return the value which is set by the method 2. Why? Because that method 2 is registered as the last invoke method in the invocation list, right? So when you are creating the delegate instance, first you registered method 1 and then you registered method 2. That means method 2 is the last method in the invocation list. As method 2 is the last in the invocation list, what this method set, that value is going to be returned into this output parameter, right? Let me run the application and show you the output. So in this case, you can see return value is true. So this is how you can work with a output parameter and a delegate. That's it for today. In the next video, I'm going to discuss Delegate real-time examples, right? I'm going to show you two real-time examples of using Delegate so that you will get a better clarity, right? That's it for today. In case you need the text document, what I'm showing in the presentation, the link for the same is provided in the video description section. Please go to the link and get the document. Thank you. Thank you for watching this.